Thank you. Good afternoon. Glad to see everybody's here and looking forward to the weekend, I hope. Wanted to get started on time. We know your time's valuable. Uh, so let's move on. There we go. So first off, know quite a few of you, but some of you probably don't know who Impact Systems is. And so we are a product development company. We have engineering services that we provide at all levels. We were founded in 1985, so we've been around a few years. And because of that, we've got very many customers, hundreds of projects, sizes from small little medical devices all the way up to underground mining equipment. So the size can be anything. We also represent products that we believe are the best in class. Those would be engineering software, of course. We're going to be talking about some of that today. 3D printers, which includes different materials, including metal, and some enterprise solutions that we offer. On the engineering services side, this is really the core of our company. And we deliver these solutions leveraging our engineering people. We've got trainers, finite element analysis people, dynamic analysis people, and we have the software expertise to really benefit clients in a lot of different ways. Our people are professional licensed engineers in some cases. We can do drafting all the way up to turnkey projects and have over all those years. We can do finite element analysis and fluid dynamics when we have those experts available on your demand. We can do a project all the way, including the project management if you'd like. And personally, I've been associated with a couple of projects which have gone from a napkin type sketch through the patent process all the way to market. In additive manufacturing, we represent a number of different 3D printers. These things are different sizes, use different materials, but they let your project team get to market quickly. And in some cases, these same machines can be used for production. And in fact, we are using one of the machines right now making COVID face mask parts for different places. These machines are also production capable. And today we're here to talk about PTC solutions. And we have a number of different solutions that, of course, PTC offers. These are best in class augmented reality, product lifecycle management, and what we're talking about today, design tools. In Impact Systems, we've got expert users with Creo, MathCAD, Windchill, Creo Simulate, various of the PTC products. We can also offer customized training and mentoring, either on your site, in our classroom, or remotely by the web. These days, it's pretty much all on the web. That's just a little tiny bit of what Impact Systems is, and I'll pass it over to Kelly.
Hey, Mark, thank you for that introduction. Can you hear me okay?
Yes.
Paul, if you can go back just one slide, that would be great for me. So I'm Kelly Knake. I'm one of the owners of Impact Systems. On our line also, we got Scott Andrews, president of our organization. He's been my business partner for 16 years now. So I just want to highlight a little bit more what Mark had said and just cover just a couple quick points. So we really are experts because we use the software. So we can train you in the software, as Mark talked about. But the reason why we can train you so well is we don't just teach out of the book or teach out of our head. Our instructors teach out of their heart because they utilize the software for engineering projects. One of the things Mark had talked about was a medical that we're doing with some folks up in Dallas. They've been on the national news. It's a different way of having a ventilator. So rather than having to intubate the patient, it's actually a big hood that goes over their head. So we worked with the customer, and because their business has skyrocketed from doing very little to a lot in these COVID times. So utilize this for the whether it be for the design, whether it be for MathCAD and utilizing how that connects into Creo and the simulation projects. I want to just highlight on one simulation project that we've actually done some things for both Speedo and for Nike on doing some goggles using the software to simulate the flow of the water across the face, the torso, and the glasses. Believe it or not, that's a highly competitive market. Paul, if we can go back one more, and I'm just going to close on this and turn it back over to Mark. So Mark highlighted the usage of the desktop metal, the HP, and the Rise for 3D printing. What we found is using Creo software and then tying it in with the additive manufacturing has allowed us to streamline companies' businesses to a very quick turnaround. So whether it be for getting a prototype out, whether doing design iterations on using the Creo software, to all the way to, as Mark spoke about, a production type part. The HP can crank out parts very quickly, and in a nylon 12, which is a good strength usage for companies in a production type setting. So I mean, it's turning into more of a hybrid world, not just traditional manufacturing, not just 3D printing, but additive manufacturing. So a little different take. So Mark, Paul, and Dana, I appreciate all y'all's time on everything. And Mark, I'm going to turn it over to you, and appreciate the opportunity to serve our customers as we have for all these years.
Thank you, Kelly. And now I'd like to turn it over to Paul Dye, who's part of PTC's Center of Excellence, to give us a look at what's new in Creo 7. Paul, take it away.
Thank you very much, Mark, and thank you for that overview of Impact, and definitely Kelly for going over a couple really good use cases there of really how we like to see using a lot of the software that we have available to us. And one of the softwares that we have available to us, and what I'm going to be going over today specifically, is Creo Parametric. Even more specifically, Creo Parametric 7.0. So outside of just the basic parametric capabilities, there's really been a ton that has been improved upon and really enhanced and brought into the ability to use now in the context of Creo 7. So definitely more than I could go over just in the context of, 30, 45 minutes, but I'm going to try to hit on a lot of it today and really go through a lot of different examples so we can see exactly how we use these things. First thing that I'm going to go over just to touch over it initially is around just improvements that we have in the core modeling capabilities. First thing we have is improvements to the import data doctor. So this is something that we use quite often if we're working with non-native geometry. What we have now is support for multi-body. And outside of that, we also have a troubleshooter that's looking for things like open quilts that you might have, and not only finding them, but how we go through and fix them. So definitely a lot of improvements there, and really useful if you're working with that non-native CAD data. We also have new display filters for geometries or representations. So whenever you're showing off these different representations, we've improved your ability to show off different features. So for example, here, if we wanted to share off this design, but we wanted to highlight on a couple different features, you could go ahead and turn everything that is in that main body here transparent, highlight, and maybe change the appearance of these different latticing features. So definitely a lot of different uses there. We had enhancements around the draft feature as well. So that's things like drafting already drafted features, and also the ability to detect existing draft angles that are right in the model. So it makes it a lot easier to work with and easier to modify later on as we keep building on top of that. And also improvements to the performance of snapping to model geometry or to a grid. So this is just another way to work where if you're wanting to quickly move about, quickly sketch onto points or edges or different parts of the model geometry, you can go ahead and turn that on, snapping to a grid for a lot of different uses. And then whenever you don't need to work with those, you can very quickly snap it off. So just another option there that we have in our quick menu settings. Made enhancements to the mirror tool in the sketcher. So it makes it very easy to grab things and mirror about, or you can essentially mirror about anything now. Just grab a straight sketch that you have and mirror about it. And then even as they make changes to it, if you want to change around the dimensions of those, your mirror feature is going to update right along with those. We made improvements to the visualization of really your design intent in the sketcher. We've improved the look of the relation icons, able to highlight references, change colors. And that's something that you'll probably notice over the past couple of releases of Creo is we've really made a lot of strides in really built out the modernization and really the look and feel for working in not only Creo in general, but even here now in the Sketcher as well. So really building out your ability to display that type of design intent throughout creating things and creating those sketches. Finally here in the edit dimension selection, you're able to set the appearance of your Sketcher constraints. That means whenever you click to edit any of those dimensions, also show the constraints. So that's another config option that we have. That's something we can edit there. So that's pretty much it for going over just a couple of different core modeling capabilities. But what I want to move into now is more into some of the applications that we work with. Starting here first with Creo Simulation Live, aka CSL. And if this is something that you haven't worked with before or even seen in the past, essentially it's a tool that we've developed as part of our partnership with ANSYS. And this is putting real-time simulation right in the modeling environment. So normally it's another software you have to jump over into, build out a mesh and run through this whole simulation, where with Creo Simulation Live, it's really just right in the same parametric modeling environment that you're used to, and it cuts out a lot of the process and a lot of the real headache that goes into really running and getting this type of benefits that you get from running analysis. You're getting that right in the context of where you do design. It's real time. So quickly first, we're going to go over some of the improvements we made around this area. So first is the ability to control the direction vector from a selection. So it doesn't have to be a default, and you don't have to go through and define all the XYZ components. You can simply just say select the direction, pick on any of the faces or wherever you want to use to define that, and it's going to build out those directions for you. And building off of that, you're now not locked to working with the global coordinate system. You can now select any coordinate system that you have defined to go through and work with those load cases. So it's just improving the general ability to define those loads at the start of whatever study you want to do. We also made enhancements to the legend. And so there's really a lot of modernization going around here as well, and really building out the utility. So you can specify what you want to look at, a lot of different display values, how they're displayed. Especially here we have one that's our composite view, where you can essentially select different areas of the legend. So if you only wanted to see values between 14.6 and 8.3, you go ahead and move those upper and lower ranges up, and then everything else is going to be pretty much transparent, and you're only going to see those values you're concerned with. And we can also use values that we get from our simulation probes in Creo Simulation Live and utilize them in our behavior modeling studies. And behavior modeling, what it does is it allows us to take values like if you're looking at your maximum von Mises stress or the displacement in a certain area and actually optimize around it. We can tell the system certain dimensions that it can change and different variables that it can use, and the system goes through and automatically optimizes that model for us based on what we allowed it to change. It's a very useful way of using some of those analysis results that we get back from CSL. And next, we've added more real-world constraint types, things like ball, pin, planar constraints, so things that exist elsewhere in Creo, but now we're able to use them in the context of CSL as well. So it's just helping us to make each of these cases more realistic to the problem or the situation you're really trying to design around. And CSL now has support for a multi-body design, which this is something I'm going to go to and talk a little bit more in depth with as well, just in multi-body in general. But obviously, there's a lot of different applications of that. Things like cavities, creating internal or external volumes, domains, and a lot more around those. And specifically to thermal studies, we can now do transient thermal studies, aka time-dependent analysis. Allows you to see how your results are changing over the course of time. So now in the context of that thermal study, either do that steady state or time-dependent. And then probably the biggest change to CSL with the release of Creo 7 is now the option to do flow analysis. In the same way that we do for structural, thermal, modal, where we're starting into this, where we're creating a fluid domain, specifying which areas that we want to include in the study, whether it's an internal or external flow, defining the inlets, outlets, and then from there, it's just a matter of specifying the materials that you want to use. And from there, you essentially just visualize it right on top of the model that you're working with. And that's the idea here, is regardless of if it's an internal or external case, be able to visualize it right on top of the model that you're working with. And around that, a lot of different options for the results that you're getting. You can visualize the streamlines, particles, take section views, direction fields, set probes. Really powerful, but at the same time, really easy to use tool for doing that type of flow analysis. Or normally, if you wanted to work with things like this, you would have to really get an expensive tool to do that, and you'd have to have that expert knowledge to go through and get real actual useful results out of. It's not, but this is something that we don't have to send off to that expert analyst. Something that us as the designer, we can work with it right in the design environment and get those type of results back right as soon as we're making changes. And that's something that now I'd like to actually go through and show a little bit about what that looks like and how we work with this tool. So switch over to our model here. So for our demonstration of going through that flow analysis, we're going to be working with a model for a muffler off of a motorcycle assembly. So this is the part that actually came off of one of our customers, Royal Enfield. So this is the muffler off of one of their data sets. What we want to do is simulate some of the flow that's happening with the system. Let's take a section view to kind of see what we're working with here to start. And there's definitely a lot of good geometry in here. You know, a couple baffles, walls, channels, things that we're going to be able to change as we go further into this. If we want to start into the study, we simply just go right up to the top, click our live simulation, and then start into the type of study you want to run. And in CSL, you have different options. You can go into structural studies, thermal, modal. In this case, we want to do a fluid simulation. So going over just the general path of what you lay out whenever you go into a flow analysis is first you're going to lay out the fluid domain that you want to work within. So this could either be an internal case, an external case. You just have a fluid domain already defined. You could select that. In this case, we're going to do an internal flow through this muffler. To do that, we'll simply define the inlet where we have the flow beginning. Switch around over to the back here, define the outlet. What the system does is it automatically builds out the internal volume for that model. Once we select OK, then that now appears down in the model tree, something that I can go back to, make whatever changes I want to later on. And from there, what I can then do is define the materials for the study. So we have a few base options laid out here that we could select from. In my case, carbon dioxide is going to be a really close approximation for what's coming out of my motorcycle. So I'll go ahead and select that. Once we have that selected, we'll then go into defining the fluid flow velocity for my muffler. Essentially, how fast is this going to be coming in from my motor? Specify the surface I want to work with, set the direction, set any of the magnitudes, even from a selection, like I said earlier, and simply go ahead and do it right like that. So now I have that flow velocity set up. I can also set up some thermal conditions, maybe if I have a prescribed temperature at that inlet, and can set the value, set the units, really whatever regular operating temperatures might be from that motorcycle exhaust. With that, I'm pretty much happy with a lot of the initial conditions I have around that inlet. So let's go ahead and move around to the back end here and define an outlet pressure. In this case, I'm just going to simply set it to 0, essentially just outside air. And with that, that's all we need to do. We have some quick options we could go through here. We could change the simulation quality if we'd like, so we could slide it all the way over to the left if we'd like to focus on the speed and really optimize around that. We could keep it all the way to the right for the highest accuracy, or maybe somewhere in between if we'd like to. In this case, let's leave it over on highest accuracy, and we can simply go in and simulate. We can see as soon as I click to run the simulation, we're getting results back. It really is that fast. And I have a lot of abilities to change what I'm seeing here over my legend if I only wanted to see the velocity within that particular range. Also have different display options that I can choose from, maybe to visualize the flow of individual particles here. And with that, even more options for that particle to change the size, change the transparency, really getting everything looking the way I want. Helps me to understand exactly how this flow is working depending on how I set my model up. Right. So those are the kind of particles are one really good way to analyze the flow. We could look at some other ones here as well. If we wanted to look at the direction field, which acts as a cut plane that I can use to see the direction everything's going. I can move that cut plane around to different parts of the model. Here I'll pull up my dragger tool and kind of change that around, see the direction that my fluid's moving based on however I defined it. Helps me really interrogate certain areas in the model. You can go through and type in specific values for that section view. As we can see, there's a lot of different ways to visualize the results. But on top of that, also analyze and begin to build off of those. Starting here first, we're going to use a simulation live probe. Allows me to see the different values in the model. If we want to see maybe our max velocity down by our outlet, you can see how that changes over the course of the flow. We can also see a graph of those values if we'd like to as well. We can see them changing, but we can also see how those are changing over time. We have other options as well to view things like pressure, temperature, vortices. Now, these are all things that we can actually begin to design around. And one of the best ways we have for doing that in the context of Creo is with the design exploration extension. This is our tool within Creo for trying out new designs, iterations, branching off of existing designs. And instead of how you'd normally do it by doing save as all the time, making copies, we simply just start into this with a pre-modified version of the model and keep it all right within this one session. As we go through and make changes, instead of saving off different copies, we're going to make checkpoints along the way. What I'll do here is for these internal baffles, what's going to happen maybe if they were a couple inches longer. So we can go through and make any of these changes we want to. And even though we're running in this design exploration session, we had the flow analysis running, we're still able to do this standard sort of CAD Creo work that we're used to. The difference is now is as soon as I go through and make any of those changes, we're actually getting insight into what that does to our analysis. We check the particle flow, see where the velocity is increasing or decreasing. Especially important down at my end velocity down by that outlet. You check that probe, see the graph, and that isn't something that I send off to hopefully get results back by the end of the week. We go through them, make the change, and see the result. And if I'm happy with the change I made, I'll make a checkpoint and show, okay, I increased the length here, so it'll call that long pipe. So we're really keeping track of all these different changes that I'm making here. What that allows me to do is keep making more changes to the design. Maybe in a past design, I may have built out these pipes or these baffles with holes in them. And I want to see how that design would work if I activated those holes. So we can go ahead and activate them and kind of see how that's changing the results here in the model. Immediately, we're seeing a really different type of flow down by the outlet. And to get a better idea into that, we can check the probe, check the graph of those values, clearly see that we're starting to increase that outlet velocity. But we can check into other values as well. We can switch over to that composite view, maybe see how the velocity is moving through our pipes, check the pressure, see exactly where we're having pressure drops. It might be useful in order to see where we're having max values occur in the model. And similar to how we did with the direction field earlier, we can also take true section views to see what's happening at the different parts of the model. So we can flip this around to the back end to see what that flow is looking like through those holes we added in. So that's one good way to look at it. Maybe we'll actually switch back over to that direction field and actually see we almost reverse the flow through those holes. So whether that is or isn't what I want, we know exactly what it's doing as soon as I make the change. If I want to start to actually capture that design intent, I can then make a checkpoint to show right where I was whenever I made those changes for the holes. Something that I can check back on later, switch between different checkpoints. It's really starting to capture the work that I've done throughout the design that I've worked on. So we're pretty much happy there. So we're going to move our attention more towards the beginning of the flow. Right now, we pretty much just have a solid cylinder with a bunch of pipes going through it, but I want to go through and change that design. So let's first clear out some of the features that we have in there right now and instead start with more of a clean slate that I can begin to add to as we go. Let's also use one of our multi-body commands here to very quickly remove that body from our model. And there we go. And what I actually want to add in here is more of a lattice feature that's going to be used to regulate the flow throughout that channel. Now, that could be something that we're going to create using additive manufacturing. And around this lattice, there's a lot of options. So first thing that we're going to do here is begin by specifying the surfaces or the area that we're going to use to define where that lattice should be placed within. That's what we call a lattice region. You can see here, we'll go through and select on any of the edges we might want to define that region. And latticing, if this is something that you haven't seen, this is a feature that we've had a lot of focus on over the past couple of releases of Creo. It gives us the ability to create some of this really robust, complex structure with a lot of different use cases. So we can quickly go through here, define our coordinate system, state where that first cell for the lattice should be placed, define what the cell shape should be. We have a lot of different options for those shapes. We could do different 3D shapes. More like we're doing here, we could set it to more of a 2.5D shape in the shape of a hexagon. If it's a little bit big, we can scale it down. And once we have it down in the size we like, we can go ahead and change some parameters about it. So if some of those walls look a little bit thin, I can increase the wall thickness. You can actually visualize it to see if we like it. If we do, go ahead and make the change. Again, as soon as I go through and make that change, even though it's a pretty significant change, the analysis has already been updated. We can go through and analyze the effects of that, change the display type, change the different result types that we're seeing. We can obviously see different flow type through there, and especially around that pressure, that we have the pressure drop moved all the way towards the middle of it now. maybe different from what we had before. We can check back down around any of the areas, change around the display types, see the values we're getting down at our outlet have changed around to see exactly what that's doing to the graph of those values. Right, and so once I've had the chance to look over the results, and because I'm in Dex or Design Exploration, build out a checkpoint allows me to see exactly where I was and what changes I made. If I'm happy with those, I can choose to accept the changes, and then all those changes are applied to that pre-modified version of the model. But even though the design exploration is a great tool, I don't have to be in Dex to make the changes to the model. It's gonna be a day or two later, and someone says, "Hey, Paul, we need to decrease that outlet velocity." Well, I know maybe one way to do that is to decrease or increase the outer diameter of that outlet. We can go ahead and make that change right there. Simply regenerate on the model, and we can see that the analysis updates right along with it. We can go back here, check in with our simulation live probe here, see that now our velocity's down around 240, 230. So it's definitely dropped down a bit. And that's really the idea with the flow analysis in CSL. So we're able to make as many changes as we want. Try this, try that, try anything. You don't want to have to limit at all the amount of creativity that you could have in your design by having to wait around for someone to give your analysis results back. You can go ahead and make the changes and see exactly what that does to your analysis. And again, that's just one type of analysis that we have in the context of Creo Simulation Live. There's obviously other examples for doing structural studies, vibrations, or thermal studies if you want to look into that. So definitely a lot of different options to go through and look at there. But for now, we can go ahead and move on to touching on some other subjects here. The next area is around multi-body design. So this is offering a new way to design in Creo and something that we've added in really to give us the ability to work with some of these applications that we now have in Creo, such as the Creo Simulation Live Flow Analysis. If we want to work with some of those domains, that's utilizing what we have in the multi-body and what we'll see in a little bit with the generative design. So a couple areas where we have some enhanced capabilities and make use of this multi-body design approach. What that does is really allow you to be flexible in the way that you design the parts in your model. So where each of those bodies can all be handled differently. You can have different materials included or excluded from your mass calculations, have them included or excluded when you define your global interferences or clearances. There's a lot of options around those. This is something that's really going to be supported mostly everywhere in Creo going forward. And each of these bodies can have even their own individual appearances, different parameters, attributes, and with each of those, we have a lot of different operators for working with that geometry. That means merging, subtracting, intersecting, and once you've done what you need to do, you can go ahead and make part files out of any of those bodies. And it's a really powerful way to work. And if it's something that you've never worked with, particularly around multi-body, it's definitely something that you're going to want to try. And for some people, the standard way of that we're used to working with in Creo is going to work just fine. You will maybe never even need the use of multi-body. But for some people that are going to be working with a couple of these new different applications, maybe things like the flow analysis or the generative design, is going to open up a new world of possibilities. So it's going to get you there much faster and much easier for some geometry, maybe as opposed to your typical surfacing and quilt-based workflow. So quick look through there. And another area that I want to look into is particularly here around additive manufacturing and really the use of 3D printing. And the first thing that we have is improvements to stochastic lattices. This is a lattice type that is creating more of a randomized beam and ball shaped lattice that's really useful in a lot of different ways, like for medical purposes or creating bone grafts. We've seen some really cool uses out of that. And what we've done here to enhance that is the way that that lattice follows along some of the hard edges of the different parts and the models you work with. So it's further making those structures even more structurally sound. Next, we've had improvements to custom lattice cells. And what this is where you're taking a part file and using that as the cell for the lattice. Where in the past, we've had the option for using full geometry, but we've also seen some people that want to use the custom lattice cells in 10 or 100,000 of these different cells. So with those, you're going to probably want to use more of a simplified B-rep geometry. So now we've introduced the use of that as well. And then specific into the additive manufacturing plus extension, we've made improvements to the tray assembly definition using that multi-body design approach. That means even within the same part file, we can have those different bodies with different parameters, wall thickness, colors, so a lot of different uses there. And on the other side of things, almost the opposite world here, we have improvements over in the subtractive manufacturing or machining. The first thing we can do here now is view synchronized toolpaths right in the graphics area, where we've always been able to synchronize those toolpaths, but now we have a synchronization menu where we can actually highlight on those to see, view, and at the same time keep track of what those are doing. And here we have multiple go home positions. So again, we've always had the go home command, but some machines that we work with now work with multiple different go home commands where you could have home 1, home 2, especially if you're working with mill turn operations. Whatever you need there, you're going to be able to do. And finally, the ability to explicitly call out Swiss turning operations. That's again, if you're working with a mill turn machine, you can fix the Z-axis and put in all the appropriate CL commands to that output file. So that's definitely a awesome thing there. If you work with Swiss turning, definitely something to keep in mind. And moving on, we've definitely made a lot of changes and a lot of support specifically around the area of detailing and model-based definition. And we see a lot of customers nowadays starting to move more in this direction of taking the information that you would typically define on the 2D side and starting to define that right from the 3D models themselves. We're doing a lot of work to support the areas and the work that's being done in that field. First, of course, we've included multi-body support for our drawings. So if you're still working with those drawing types and you have these different bodies with different materials, even if they're right in the same part, you can go ahead and make different cross hatchings, just different ways to further differentiate them. We have repeat regions in the drawings for those multi-body parts, or exclude certain bodies and include all that right in your tables. Then over in the drawing model tree, we have the control of those different bodies. So I can identify them, hide them, and just our ability to keep it all straight. We can configure drawing tooltips. So you can click on the view, see what the part is, see what the model, combination, check out the exploded state. So you can do it all right from there. We also have a new summary view command where we can click on an element and have the system tell me about it. It's a good way to understand the design intent, especially if you weren't the one that created it, but you're viewing it. It's definitely a good way to see that there. We have improvements around the addition of drawing tree columns, so adding those in as an option now. And around that, being able to sort the drawing tree by view models and parent views. So building out the drawing tree how you like it. We've made improvements in the area of removing hidden lines. So if you want to view those and remove some of those lines and exactly how those show up, it's much easier to do now, and you have the options around doing that. We also have the ability now to move the arrow with the name or whatever it's linked to. So you can kind of link the two, so whenever you move the name around, the arrow is going to follow right along with it. Or you can break that connection, either way. You also now have the option to add multiple leads. So there's an option where you can have multiple normal tangent leaders, all coming off of that one common annotation. And that's really helpful for particular GTOLs, notes, symbols, anything that you want to add that's referencing those different areas throughout the model, even if they change. Next, we're able to align ordinate dimensions with the baseline. So this is something that you're going to run into if you're working with the ANSI standard, and it's how they like to do it. So we built out those ordinate dimensions to work very well with those baselines. We can control the length of intersecting contours. So just beyond that intersection point, you can enable intersection witness lines now. We also have child view identification. It's very easy to see where your drawings go to, especially useful if you're going to be working with multi-page drawings. Or again, even if you weren't the one that created the drawing itself, it's really helpful for keeping all of that straight. We've continued to make improvements around GTOLs. So now have additional indicator values, things like intersection or collection plane for angularity, in that case for the ISO standard. We have options for controlling the gap between a GTOL and the indicator frames. So depending on the standard that you're working with, if you're working with ISO 1101 2012 or 2017, you have different options for that potential gap size. And around those standards, as they keep getting released, Creo is going to keep evolving right along with them. So now we've included support for both ISO 1101 2017 and also ASME Y 14.5 2018. Right, lastly, touching in here, if we have some options for the alignment of spacing when it comes to GTOLs, depending on how you want those GTOLs to align, on the left, on the right, that's all done keeping up with those different standards. Here we've added new symbols to the symbol palette. We've been really enhancing and building out a lot of those different symbols. So particularly we've added in the angularity symbol for an intersection plane, the runout symbol for a direction feature, and also the symmetry symbol for a collection plane. So if you work with any of those, definitely a nice added feature there. And finally, we've updated the parser for our syntax checker. That's taking into account now all those new standards and making sure it all runs well. These are, again, a lot of areas that a lot of people that we work with tend to work in and really have to abide by a lot of those different standards. So definitely a lot of really welcome changes made in those areas. So that's a nice area that we've seen there. And really taking a left turn here, what I want to talk about is probably one of the biggest developments with Creo 7 is the introduction of generative topology optimization. So generative design, in short, autonomously creates optimal designs from whatever set of system design requirements you have. So right in Creo, you're able to specify the requirements and the goals, and the generative engine is going to automatically produce a manufacturable design that you can either use as a starting point to start to build off of, or even as a final solution. And around that, you're able to try lots of different materials, physics, manufacturing constraints, and automatically generate that geometry. Allows us to try out many different generative design studies, kind of explore all different kinds of design alternatives, and at the end compare the results between each of those that you got. So you can start working towards that most optimized design, and it really gives you a great place to start from and really build off of. And while we're doing that, we're able to visualize all of that generation real time. And even when we go back and modify some of the input geometry, change around the design criteria, that's going to automatically update the results that we're getting. Once we get those results, we are able to go through and interrogate, review the analysis results, see where our stress values are, what the deformation's looking like. And as we start to get those results, go back and change things. Change around the design constraints. If you have different goals you want to try out, different geometry, try different materials out. It's really a ton of different options and a ton of different ways to build out that model. So you're really starting to get an idea of exactly how that geometry is acting and what you need to do to get it to really fit into the goals that you have for it. We're able to do all this because it's integrated right in Creo. It's not some other software we have to send it off to. We actually integrated this Frustum technology right into the modeling environment. It's not some separate window or software we have to switch over to. All we do is define the geometry, say what things we can change, say what things we can't change, any constraints we might have, and just let the system go. And once the system generates that design, and you have the chance to review it, you can go ahead and output the results to use elsewhere in Creo for further refinement. So if we want to do that, we can simply take that design and actually convert it to solid BREP geometry. So we have different options for how the model is reconstructed, essentially. We can go back and forth between the two, see what's changed, and really do all of this to get the best model possible, but at the same time with real manufacturable geometry. We don't want to just have this tessellated file that's nice to look at. Want to go ahead and actually create a file that we're able to work with and really use out in the real world. Right, and so this is another area that really makes sense more as I can go through and show exactly what it looks like. So we can go ahead and jump into an example here. And so here's the model that we're going to be working with. So this is actually that overall assembly from where we took that muffler off of earlier. This is the Royal Enfield data set using that motorcycle. I think this one's actually the Enforcer motorcycle. And we're going to go ahead and take a look at, particularly up here, into our steering mechanism, more specifically down here on this lever yoke. Right now, works perfectly well. This is actually something that I want to see if I can cut down on some of the material around this. I might know some of our different design goals that I'm after or what I want to use, but I'm not exactly sure where or how I'm going to get there. Well, that's a perfect candidate for working with generative topology optimization. So let's go ahead in here and open up the part that we're going to use to get working. So here we can see that same yoke part, but a little bit more of a simplified version of it. And so this is going to be the base that we're going to begin to build off of. So this first starts with having our envelope of area that we're going to build out within. This is essentially the overall area that we can design within. And then next we have our preserved geometry. Essentially, that's the area that I want to keep. And that's something that I'm going to build out in the middle of. If we want to begin into building, we simply go right up into our applications, select our generative design, and then go through and lay out our design. Okay, the first thing that we're going to do whenever we're laying out our general design and our generative process here is saying the starting geometry. So that's again that envelope we began with. So we can pick that right out. So now it's going to be more of a transparent area. You can't really see it right now because it's essentially overlapping with that preserved geometry, but we're going to be able to build out in that gray area that we saw. So next we'll have that preserved geometry laid out here as well. So that's again just the area that we want to make sure is included in the final design. Here we'll go through and apply some of our constraints. So in this case here we might have a pin that's fixing this design right down there in the middle. And then we'll lay out our loads that we want to study. It's going to be forces, moments, pressures, centrifugal forces. Over here we know that we're going to have some different forces applied on the outer surfaces of that yoke. So we'll lay those out here. So now that I have some of those different initial conditions laid out, it's time to say what we want to design for. So what our goal is going to be. Well, I'm trying to take weight out, so we're just going to fill about 2/3 of that volume. And then also we have some different manufacturing or design constraints that we can build out. So here, if we know that we're going to be, taking into account the build direction for additive manufacturing, maybe a parting line if you're doing a cast, or on the other side of it, it could be down here with our geometric constraints. Just making sure maybe here we want to make sure that it's going to be uniform on either side of that plane there. So on the left-hand side, it's going to be the same as the right. Finally, we'll lay out whatever material that we're going to work with here. So in this case, it's going to be more of an aluminum alloy. And that's all we need for our design criteria. A couple different options we can change before getting into it. We have some options for our general fidelity, how detailed we want it to get, minimum element size that we can type in there, maximum amount of iterations we want to run. In that case, we'll just leave it kind of right where it is for right now. And with all that laid out, that's all we really need to do. And from there, we'll just click to optimize. And so now the system's taking this physics and all the design criteria, and it's automatically building out our design. We can visualize that all real time with all the different steps and iterations it's taking, and we can analyze the results from our study. So right on the model, we can take a look at our von Mises stress, see exactly where we're getting maximums and minimums. Let's move up to the top of the model here to check out maybe where our hotspots are going to be. We have different display options for looking at the displacement, maybe see if that part's deforming in the way it should be based on the loads and the constraints we set up. And even take it one step further to understand it and actually animate on that deformation. We can change the speed of that animation, change the scale. It's a very visual way of doing it. And if we're not happy with the results we got back, we can just as easily go back and make changes to the definition of the study. But if I am happy with what I got here, I can now choose to generate that design. I'm going to now take that tessellated geometry that I have now and reconstruct it as a boundary representation, aka BREP, that I can take over into Creo parametric. Rather than being just stuck with that tessellated file, we're now getting real manufacturable surfaces, aka curvature continuous, that we can begin to work off of. So what Creo is doing now is it's going to reconstruct all that geometry that we just went through and built out in the study. And now it's just part of the Creo model, something that I can add right back into my part. Here we can just use some of those multi-body Boolean operations to merge our new geometry and add it back in with that preserved geometry we began with. And just like that, we now have a solid Creo model. It's ready to go. That's something that now I could take over and work with it in other areas, right? But now what happens really is a lot of times at this point, maybe the model has to change, or somebody else on my team says, hey, Paul, that outer diameter, we got to move that. We got to scale it down, scale it up, whatever it is. But does that now mean that I have to start everything over from scratch? Well, no. All we do is go back in, change around whatever we want our design goals to be. In this case, we actually want to change up that design criteria, right? So we'll still maybe type in a limit volume there, maybe increase it a little bit, still have it be symmetric about that middle plane. But what I want to change here is actually, in this case, maybe I don't have a 3D printer. Some of that geometry just isn't possible without the use of 3D printing. Well, again, that's no problem. I go into whatever manufacturing techniques that I use. So here, I want to build this out as a linear extrude. I can build that out and simply have it be done that way. So I could really build this out for whatever manufacturing techniques that I have available to us. We'll add in those materials. go through and check into our study settings. We want to change any of those around before jumping into the study. Really anything that we want to go through and change that. And so in this case here, I've already gone through and run the study before. So maybe instead of running through all that again, we can go right into the File Explorer and open up the result that we got after converting to the BREP geometry. Whereas before, this design was really only possible using additive manufacturing techniques. This is a part that could be used, for milling. This could be used for casting, extrusion. So that's something that we can work with now and actually take further and do analysis on, make changes to the model. And like we saw earlier with working with Creo Simulation Live, we could maybe even do more of a structural study around this. So taking those loads and constraints we saw earlier, go ahead and work with it here and make changes and see exactly what it's doing here right in Creo Simulation Live. Again, with Creo Simulation Live, we can see right as soon as I click to run the simulation, we get results back. I could go out and try all different kinds of designs through generative. Take them there, reconstruct the geometry, move all those constraints and loads over into my simulation, and see what kind of results we're getting. So look at these ones here. We're definitely getting a different result from what we would have with the additive model. Some of that deformation is changed up around those outer holes. We can still go through and animate on it to really understand it. So we can take that info, run more analysis, go back in, build out more designs. Really, it's whatever you want to do there. So that's a really quick look through what you can do there, but what you can see is it's really at the end of the day giving you the ability to create really innovative, but at the same time, structurally sound models, maintaining all the structural requirements you might have for it, but at the same time minimizing on the material that's needed to get you there. So just a brief look through there, but a general look into really the future of how we see people working with design and how we see it going moving forward. What I want to take a look at now is just a couple other areas that we've really made enhancements to. I want to touch on here first around the Render Studio application. The first thing here is the ability to pause and resume during the rendering. Normally, you'd kind of have this mode on constantly running by default, but here now, if you know that you're going to have to go through and make a couple changes, you can simply just pause that render and then give the computer a break from running. We can also render the mannequin vision window, essentially taking the view of what the mannequin can see. We're able to render that view to get some really nice shots. So also now the option to define a custom floor plane for the render. It allows you to flip the model around, change where the shadows are, the reflections are appearing. So you have that added level of customization, and we've really built it out to be easy to work with there. So a couple of things there, but next is around the area of augmented reality in Creo. And this is where we're able to view these models as augmented reality experiences. This is something that I think we've been building out since about Creo 3 or 4, is the idea of building out these AR experiences from our models. So as opposed to just sending out pictures of the model or maybe sending out a step version of it where they have to try to pull it up on whatever CAD software they're working with, what we can do is actually share it off as an augmented reality experience. It's something that now you can have your customers, you can have your resellers, or even other internal people pull it right up on their desk, scale it around, see what it looks like, and really actually start to interact with it more than just looking at a picture of it. And around this, we've also now included the ability to publish combined states as part of those experiences. Those combined states can include exploded views, different sections, different appearances, and that can all be included now with that AR experience. And with those different states, the user can switch between each of them, so very quickly and really easily switch between one view to the next. And you have within the V4 View app, which is our free to download, free to use application for actually pulling up and viewing those experiences, you can change between all those different view options. And then finally, now what I'd like to briefly talk on here is some of the improvements to the Easy Tolerance Analysis tool in Creo, formerly known as the Tolerance Analysis extension. And if this is something that you haven't worked with before, it's a one-dimensional tolerance stack-up analysis tool, something that's powered by one of our partners, Sigmetrics, to perform these tolerance analysis right on our Creo assemblies. Something that you can do right from the Creo design, works right from the annotations that we have for our dimensions, the tolerances, GD&T information, and as we make changes, have all those changes propagated to update the analysis data that you're getting. So around that, you're able to work with it in this really streamlined, modernized appearance that we've done a lot to update the look and the feel of the tool, made it even easier and faster to do these dimensional stack ups, even if we aren't the analysis guru, or as the designer, able to actually get a lot of value out of working with this. You can define multiple different stack-ups per model and evaluate the impact of those studies to look at things like statistical results, defects, worst case scenarios, RSS, even looking at which annotations have the highest contribution to the results that you're getting. So if you have one part or one feature or even one tolerance that's having a large contribution, maybe you could go ahead and tighten up that tolerance in that area and kind of see how that's changing the defects per million that you're getting, all those different types of values. All right, so obviously a lot of information there to go over, but really wanted to hit on a lot of those different areas. There's a ton of work being done as we keep moving forward with Creo 7 and beyond to build out all these applications. So wanted to give a good general overview of that. What I can do now is pass it back over and we can take any questions that we might have.
Thank you, Paul. It was very informative. We do have a couple of questions. If you have any questions, down at the bottom of the screen, there's 3 dots in a circle. That's where the question button is, and just type your question in. I think there's a 256 character limit. We do have 2 questions already. The first question, will Creo Simulate Live Fluid Dynamics be able to run in Creo 6 or only in Creo 7?
I believe right now it's set for Creo 7 and I think also for Creo 4 M130. And the reason for that is because it's utilizing those new multi-body features for defining the fluid domains. So I'm not sure whether in the future it will be moved back onto Creo 6, but as of right now, it's going to be on Creo 7 and forwards, and then also back on Creo 4 M130.
Thank you. Next question, can we have a displacement or stress constraint in generative design?
I believe that's an option that you have available to you as one of the constraints. I can actually check back real quick on what some of those constraint types are for you. So you can have fixed constraints, you can have displacement, you can have planar, and you can have cylindrical. So yeah, you can define a predetermined displacement before running through in the generative design.
That's all the questions we currently have, so we'll give you a minute or so to type your question in, and please, if you have a question. It says on design goals, so the displacement or stress constraint on the design goals.
Oh, and the design goals.
Right, not the supports.
I don't believe in the design criteria itself you can define that. I believe that might be something that you would simply, whenever you go through and run the study, you could lay out your other design goals, and then whenever you get the simulation or the analysis results, you can check in with those analysis. You can actually see what types of deformation you're getting. So say you wanted to stay under 2 millimeters of deformation, you could define everything else about your study, go ahead and run it, look at the simulation results, and then see the deformation that you're getting and use that as a gauge. And still kind of working in the same way as you would defining it as a design goal, really.
Okay, this last chance. If you've got a question, please enter it.
Mark, I just want to comment. This is Kelly again, and Paul. Great job on the presentation. A lot of valuable information. We always Impact Systems Engineering always looks forward to partnering with PTC, especially on the Creo 7 software. Mark, for all the customers that might have come on after the intro call, remember Impact Systems is your engineering source for purchasing the PTC software. If we can give you a specific demo on anything else, whether it be MathCAD, Simulate, anything beyond that on the PTC side, we'd greatly like to help there. PTC is doing great things towards the milling and towards the 3D printing, as we had talked about earlier, for doing additive manufacturing, whether it be on the with HP or Desktop Metal, the two other partners that we've chosen to partner with on the additive side. Mark, I think Andreas commented further on his question.
Yes. On the flow simulation, can we compute the temperature?
Yeah, so you can see the temperature that's moving throughout your model. You won't be able to see the temperatures of the surrounding solids. That would be more of a conjugate flow example, but that would be something that you would probably start to do more in the Creo flow analysis partner. That's one of our ones that we have, are more, I guess you could say, higher end flow analysis through our partnership with Cimerix. So that would be something that you would start to get into there. But you do have options for seeing kind of the temperature effects throughout your flow in the Creo simulation live flow analysis though.
Paula, those are all very good questions, great answers. Mark, I think you're going to be following up with everybody on that signed up for the call, just to see how we can be further helping them with the Creo 7, whether it be further demonstrations or even trial licenses or selling them the software. Correct?
That's correct. We got.
I think we're at the top of the hour, and I think
Yes.
that's set for this. And so I want to thank everybody for attending. Mark Mosier is going to be following up with everyone. Paul and Dana, thank you for your participation in setting all this up. We appreciate all your assistance and support in the endeavors to get Creo 7 more out into the world.
Thank you very much, Kelly, and thank you everybody for jumping on today.
Goodbye now. Y'all have a great week.